Hey, this is a demo of an ALC60X argon laser head. The head has about 195 hours on it, so it's pretty new. It's rated for 100 milliwatts or less, and it is multi-line. So what I thought I would do is fire it up, show you how the temperature and the current and the output change. We'll ramp it up full and ramp it back down and cool it off. So we'll just point some things out here. Here's a multimeter. It's set to read the voltage on the output of the head. There's two jacks down here which will read current, and these two jacks will read output level. But the output level is only an approximate because the metering inside isn't calibrated. Well, it isn't accurately calibrated. The current's pretty accurate. I have to push this white button to get a reading. It'll read out on this meter, and for every 0.2 volts, there's an amp. So if it says 0.2, that's 1 amp. If it says 0.4, that's 2 amps. If it says 1 volt, that's 5 amps. You just take the number, divide it by 0.2, basically. Here I have a temperature sensor in Celsius. It's a K-type thermocouple, and it is in the cooling fin close down to the beryllium oxide bore. So that'll give us a read of the temperature and pretty much the ambient temperature, or maybe the outside of the bore temperature. But that's a good thing to read. And here's a laser power meter with a thermopile. This is made by Ken Rowe. He makes the Kenometer Pro, and it's kind of, the display's getting a little blown out in the video, I think. So what I'll do is I'll read that just in case it's not showing. So basically what we do is we're going to start the fan, get the fan up and running. Then I'll turn the power supply on. The power supply has a delay. After the delay comes on, then it'll fire. Now, good practice with these argon lasers, these small gas air-cooled ones, is to start them on high. So I'm going to start it with the current completely cranked, and then I'll bring it back down to idle, and then we'll sort of take it from there, watch it heat up, see what the current is, see what the output, light output is, and then I'll ramp it up, and then ramp it back down, and we'll cool it off. So let's start. Now, the other thing is that my probes in the meter, I don't have banana plugs, so I just have the probes kind of sitting in there. So you might get fluctuating readings. Anyway, here we go. We'll plug the fan in and get that rolling. So we're showing about 27 degrees Celsius. And of course, no output. I'm going to turn the current output on the power supply. Power supply is now turned on. I'm going to have to adjust the thermopile for the meter once the thing fires, because it's not aimed. It's not quite aimed where it should be. So of course, nothing hasn't fired yet. Once it fires, I'm going to bring the power down. It's going to fire in a minute. The power supply just kicked on. So there it's up. And then I'll bring power down. And then I'll adjust the thermopile. Okay, so the output on the meter is reading around 8 to 10 milliamps. The meter's not so good for low readings, but you know, that's sort of approximate. We have 52 degrees Celsius on the thermometer and a current reading of 0.84, so that's 4.2 amps, and that's at idle. So the temperature at this power usually is around 50 to 60. So still at 4.2 amps. So now I'm gonna increase the power up to 20 milliwatts. Okay, now we're at 20 milliwatts. Tube current 1.16, so that's about 5.5. That's about almost 6 amps. Temperature's going up. There's 68. I'll just wait for it to stabilize a bit. So that's at 20 milliamps. So basically the maximum tube current is about 10 amps. And at 20 milliamps, we've got about 6 amps going into the tube. And the temperature now is at 71. Coming out of the fan, it's, lukewarm, I'd say. Alright, let's take it up to 40 milliwatts, I guess. So here we are at 40. Okay, temperature's climbing. Let's see what our tube current is. So now we have 1.4, so that's 5, 7, it's about 7.5 amps, or 40 milliwatts of power. Temperature's at 86, so we'll take it up to 60, I guess. Should probably do this logarithmically, but whatever. Take it up to 60. So there's 60. Temp's going up. Current is now at about 8-ish amps. You can see the back reflection on the thermal piles getting higher. So at 60 milliwatts, we're drawing about, 8 amps, 8.5 amps, and the temperature is about 101 and climbing a little bit at 62. 102. Now we're getting some warm air coming out of the fan. So that's at 60, where you can take it to 75. So there we have 75. Tube current is at about 9.125-ish amps. 75 milliwatts on the output. There's the beam. It's multi-line. So still 75. And get the temperature up there. So what did we say? Something like I think it was 8.5 amps. Let's see what we got now that we're warmed up. Still, well, it was 9 something. So that's about still the same. Still drawing about the same. A little over 9 amps. 75 milliwatts output. Sorry if I keep saying milliamps when I mean milliwatts. All these units. We're at 114 Celsius, so that's getting up there. I mean. It's a 250 CFM Pabst German-made wide-mouth fan. Basically isn't exhibiting any resistance from the head, so it is good airflow. I'm not really sure what the temperature max to run these heads at is, but I think that's okay. I mean, we're not getting way up there. All right, so let's I'm going to take it to 85 and then we'll take it to max. Okay, so here we're at 85. Tube current is almost 10 amps. It's like just under 10 amps. About 9.75 amps or so. I mean, the resistor in there is probably got a wide tolerance, so it's not entirely accurate. So 85 milliwatts. There's the beam. It's that gorgeous argon, kind of greenish blue. It's multi-line, so it has a really strong blue and green line. Temperature is at 120. Good, nice warm air coming out of the fan. Tube current still where it was, just under 10 amps. So now we'll crank it. So cranked up, we're getting about 95 milliwatts. Tube current 2.057, so that's 10.25-ish amps. Temperature is 125 and somewhat steady. Yeah. Now we're getting, you know, hottish air out of the fan, so that's good. Want to get that heat out of there. There's the beam. It's nice and bright. At this power, you know, it'll burn you a little bit if you leave your hand in there for too long. It'll smoke a match or whatever. It's really just, it's the beauty of the argon beam, not its destructive power that's interesting. I mean, it's just gorgeous. I don't know if I can use this lens to frack it down a bit. Let's see. It's just beautiful. Gas ion laser light is amazing. You can kind of see, I don't know if the camera picks it up, but I can kind of get a bit of a spread on the beam and get more of the green line reflecting than the blue line. It's pretty nice. So still the same current, still getting about 95, 96 milliwatts out of it. So temperature 128. There we go. So now what I'll do is I'll bring the power back down to idle. Now there's some information about guidelines, if you will, about how to shut these things down. The idea is you don't want to cool the tube too quickly because you want to reduce thermal stress. So how do you know when to do it? Well, having this temperature monitor helps. So I can basically, you can see the temperature dropping. The tube is still on, the laser's still on idle, and it's dropping about 1 degree a second or so. Just check the current. So 4-ish amps being drawn. Oh, and the other thing is that at this idle, basically the green line goes away, so it's a deeper blue. You might be able to see if I take something white. I don't know if the camera's picking that up a bit. I don't know. We'll see. And as I increase the current, you'll see it. You'll see the green come in. Maybe if the camera picks it up. See, there's the green coming in. Makes it a little more blue turquoise. If I bring it down, the green goes away and it's more of a blue. We'll see. I don't know if the camera will pick that up. Anyway, so when we ran it at idle, you may remember that the temperature was at around 55. So that's what I like to aim for, 55. At 55, then I'll turn the laser off, and I'll let the temperature drop a little bit more to around 40 or so, and then I'll unplug the fan. I suppose I could calculate the optimal time temperature to turn it off, but just a diffraction grating. Takes a little while to get down there. If it's stable here, like, I mean, it's not always going to be accurate. If it's stable here, then I'll just wait a little bit, and so that's pretty stable at the moment, about 64. So I will turn the laser off, and then at around 40, I'll unplug the fan. Now, it'd be really helpful if you had one of these and you had an argon laser, because then you could actually see the temperature and make decisions based on that. You can get these on eBay. They're pretty cheap. They're usually less than $20, and as you can see, it's worth it. So then at around 40, I'll just unplug the fan and just let it drop naturally. So, and in these lasers, there's a circular fin around the bore just underneath the fan, and you can stick the thermocouple from the digital thermometer in between one of those fins, down close to the tube, and that'll give you a pretty accurate reading. And that's basically it. Hopefully that was helpful.